Hello students, welcome back to my channel. Today we'll study the topics of dynamics. That is, I will give you a detailed summary basically of formulas which would be useful in dynamics, the subject taught in university level as an optional subject. Now let's get started. Dynamics is basically study of accelerated motion. Now let's quickly summarize it with the help of important formulas used in dynamics. Average speed is equal to total distance over time, total time. Velocity is equal to displacement over time, also written as dx by dt. Acceleration symbolized by f is dv by dt, that is velocity per unit time, which is equal to d square x over dt. It is also written as v dv with respect to dx. Now, in some cases like this, velocity at point P is along the tangent at point P. Now, some of the conversions: 1 kilometer per hour is equal to 5 by 18 meters per second. 1 miles per hour is equal to 22 by 15 feet per second. Now, in case of acceleration, when acceleration is negative, we say it is retardation, and we say that it is directed towards the origin. And when f is positive, then it is directed away from the origin. Now, motion in a straight line. Newton's इसके जो basically formulas हैं, that is P is equal to U plus Ft. Second is S, distance is equal to Ut plus half Ft square. P square is equal to U square plus 2 Fs. Some of the formulas. And average velocity is equal to U initial plus final velocity का mean, which is also equal to velocity at the middle of time interval, that is at t by 2. Now, distance at nth second is equal to u initial velocity plus f by 2, 2n minus 1, distance in nth second. Now, what do you mean by dead heat? It basically implies that the particles reached the destination at same time. Now, basically a theory: when A catches B such that velocity of A is greater than velocity of B, but velocity of A हमारे पास basically यूनिफॉर्म है, and B की जो velocity है B is continuously gaining speed due to acceleration, then B overtakes A, and therefore we say that A and B are together twice. When A catches B and when B overtakes A. Now, what do you mean by space average? Is equal to 1 by S 0 S V ds, which is space average is greater than time average, which is equal to 1 by T 0 T V dt. This is space average and time average of velocity. Now, motion under gravity. If we consider upwards motion, then we take g to be negative, and if we take downwards motion, then we take g to be positive, and same formulas apply. In place of f, we write g or minus g accordingly. Now, what is the basically value of g? G is equal to 9.8 meters per second square, or 981 centimeters per second square, or 32 feet per second square. Now, when motion of a lift, when lift is descending, then we take acceleration to be g minus f, where f is the acceleration of the lift, and when lift is ascending upwards, then we take it to be g plus f. Distance is also equal to area under the velocity time graph, and acceleration is also equal to slope of velocity time graph. Now, what is linear momentum? It is the amount of motion possessed by the body. Momentum formula is P is equal to mv, where v is the velocity. And by second law of Newton's law, we have that force is directly proportional to rate of change of momentum, which in turn implies F is equal to, means when we do certain experiments, then we come to know that F is equal to mf, weight, W is equal to mg. Now some of the conversions. फोर्स की यूनिट एसआई यूनिट क्या है हमारे पास न्यूटन, सीजीएस यूनिट है टाइम्स, और एफपीएस यूनिट है पाउंडल फोर्स का. 1 न्यूटन इज इक्वल टू 10 raised to power 5 times 1 ton is equal to 2240 pounds, or 10 raised to power 3 kg. Sometimes for 1000 kg we also write metric ton, and 1 pound is equal to 16 oz. 1 kilogram weight is equal to g newtons. Now, for distances, basically, radius of Earth is equal to 4000 miles, or 6.4 into 10 raised to power 6 meters. 1 mile is equal to 1760 into 3 feet. 1 feet is equal to 12 inches and 100 weight is equal to 112 pounds. We also have some more conversions, that is for energy. Here SI units joule. 1 joule is equal to 10 raised to power 7 ergs. Ergs is its CGS unit. Now smooth pulley. Light inextensible string over a smooth pulley containing two weights M1 and M2. Tension is uniform. Then we have two equations, that is M1F is equal to, since motion is downwards here, M1G minus T and M2F is equal to T minus M2G. इन दोनों को ऐड करके हमारे पास एक्सेलरेशन निकल जाएगा, देन हमारे पास टेंशन भी निकल जाएगा, and total pressure on pulley is 2P. From here we can see. Now another examples of pulley which we have is on a smooth horizontal table at the edge, pulley is here. Here mass is lying M1G. Here also mass is lying on a table M2G. Mass का reaction R. Tension T. Here also tension T. Acceleration F. Acceleration F. Now in this case, pressure on the pulley is in this direction, which would be root 2T, because this is 90 degree. This angle would be 45 degree, therefore root 2T. Now in this case, tension is equal to M2F by using this, and M1F is equal to M1G minus T. Hence we can find the acceleration and tension. Now on a smooth inclined plane, this is inclined plane at an angle alpha. Here is the mass M. Here we don't have any pulley. I'm just telling you about the acceleration which we will take. Here it is mg, mg cos alpha, mg sin alpha. Here it is reaction. Here the acceleration. Here f we take is g sin alpha. Now, if we attach a smooth pulley here such that pulley is here and a mass is also attached to it. Here it is mass M2 suppose, and here the mass is M1G, tension T here, and it is downwards and it is moving upwards. Then more equations which we have is M1G minus T is equal to M1F, M2F is equal to T minus M2, M2G sin alpha, and R is equal to M2G cos alpha. Now, if the situation is that we have inclined plane on both the sides. Says that this is beta, this is alpha. Here we have a pulley with mass attached. Here also we have a pulley with mass attached. Its mass is M2G. Its mass is M1G. This is M2G sine beta. This is M2G cos beta. This is reaction R2. Here it is acceleration T, tension T. Here it is reaction R1. This is M1G sine alpha. This is M1G cos alpha. Then we have the equations. R1 is equal to M1G cos alpha. R2 is equal to M2G cos beta. M2F is equal to T minus M2G sine beta. M1F is equal to M1G sine alpha minus T. From here we can calculate, adding these two equations, we can calculate acceleration and hence we can find the tension. If we have a rough inclined plane, then in that case we have mu r in opposite direction to the motion. That is, in above case, if motion is moving, in this case here, then mu r1 would be here, and in this case, here it is mu r2. In upwards case, motion is moving this side, so we'll have mu r here. Similarly, motion moving this side, we'll have mu r here, and just and it would be added in the equations of motion. Now, motion of a body inside, outside, or on the surface of Earth, outside, inside, and on. How the basically acceleration due to gravity or acceleration varies. Motion outside, acceleration is inversely proportional to the distance from the center of the Earth. Acceleration is directly proportional to distance from the center of the Earth. G is equal to at center of gravity. Now, let's talk about a to and fro motion. Simple harmonic motion. We have is its equation is, we say then the motion is simple harmonic. D square x over dt square is equal to minus of mu x. Here mu is important because by this we can find time period t is equal to 2 pi over under root mu. X is equal to a sine mu t when t is measured from mean position. Here it is mean position. It is moving like this. A dash, O, and these are extreme positions. When T is measured from extreme, then we take value of x to be A cos mu t, and in above case value of V is equal to plus minus mu a square minus x cube. Last step. String by Hooke's law, we know that tension is directly proportional to the extension over natural length, that is, modulus of elasticity into the extension over the natural length. P is equal to mg m d square x over dt square lambda x by L, which in turn implies mu is equal to lambda by ml, and hence we can find the time period of oscillation. String becomes slack. What do you mean by this? That it is under gravity and tension is zero. Now let's talk about simple pendulum. M d square is dt square is equal to minus mg sine theta, which in turn is equal to minus mg theta. That is minus mg s over L, and hence mu comes out to be g over L, and therefore time period of oscillation is 2 pi under root L over G. Now it is like this: one complete oscillation from this, then backwards, then this, then again to this. Two times it comes. Then we say one complete oscillation. What do you mean by beat? Swing from one extreme position to the other, which is t by 2, and from this place to this only. Now in seconds pendulum, time period is 2 seconds. That is, it take only 1 second for one beat, and therefore we can calculate that L is G over pi square using the formula. Change in number of beats, where N is number of beats, we can derive a formula that dN is equal to N by 2 dg over 2 minus dL by dg over g minus dL over L. If we need only a single quantity out of gravity and length, take one, assume 1 to be 0. Now, at top of a mountain, if we take seconds pendulum, then dn, height h, dn would be minus n h over r, and g is equal to mu over r square. Depth means basically under beneath the earth's surface. G is equal to mu r, and dn is equal to minus n. D is the depth of a mine over 2r.